Hello, welcome to this new session. My name is Philippe Oziel. I'm a developer advocate at Salesforce. And today I'm going to be presenting how you can work with APIs and integrations for the Salesforce platform. Before I jump into the presentation, let me share some useful links on how you can reach out to us. First, there's our developer website, developer.salesforce.com. There's also Twitter @SalesforceDevs and any other social channels. Just search for Salesforce developers. That being said, let's jump into the topic at hand. At Salesforce, we have a wide range of solutions that allows us to build seamless integrations. Here we can see the three pillars of the Salesforce platform. Salesforce Core, the base on which we've built the Customer 360. Heroku, our PaaS, our platform as a service, that lets developers build scalable apps in any language. And finally, MuleSoft, our middleware that allows us to build scalable integrations much faster using pre-built connectors. These three pillars work together in an API-first driven approach. They deliver interoperability across all of our systems. We won't present these solutions in detail in this session. We'll only focus on the API integration options for the sake of time. If you want more information about each of these pillars, you can check out the first video of this series. What's so great about the platform is that it gives you plenty of options to integrate with apps easily. There's a broad range of integration features that let you integrate with or without code. You can even build event-driven architectures with streaming events and pub/sub patterns. We'll cover some of these features in the following presentation. So let's dive now through the Salesforce platform and let's take a look at the various integration features. We'll go through this diagram step by step and I'll present the different features and share some demos. Let's start with APIs. This is the most powerful integration technique, but it is also the most technical. APIs let you connect Salesforce Core, Heroku, MuleSoft, and third-party systems together. Salesforce Core exposes a set of native APIs as well as some web services. Heroku can consume and expose APIs in custom code running on compute dynos. And finally, MuleSoft can consume APIs with a set of built-in connectors, and it can also expose APIs with the Secure API Gateway. Here you can see different arrows that link the three different pillars with external applications, and they represent the interconnections that are possible with APIs. Now, if we look at the Salesforce Core APIs in details, you can see here in this overview that we have a number of different APIs. There's more than 10 different APIs. The core APIs are version and specialized to specific use cases, data and metadata access. We won't have time to cover all of them today, but I'm going to present the most important ones, the ones that are wrapped by this dashed line here. That's the REST API, the SOAP API, bulk and streaming APIs, as well as some custom Apex APIs. Let's start with the data APIs. Salesforce Core exposes a set of data API endpoints that allows you to describe standard objects, like the account object, and perform CRUD operation, create, read, update, delete on the associated records. One of the great features of the platform is that whenever you create a custom object like a property, the platform auto-generates a set of endpoints that allow you to perform the same operations as standard objects. The data API's endpoints are available with the SOAP and REST APIs. The SOAP is generally used for legacy server-to-server integrations, whereas REST is better suited for web applications. Let's see an example of the REST APIs. We're going to use the eCars sample application to drive our demos. eCars is a fictitious electric car manufacturer that uses Salesforce to support their sales and service operations. This sample app is open source and you can check it on GitHub along with our other sample apps. When building the eCars app, we've created a number of custom objects, and the vehicle object is one of them. Here you can see that it has a number of custom fields that describe the vehicle. Things like the interior color, the model, the owner, etc. When we create custom objects, these can be used within the platform like we can see here in this inventory view. On top of that, we can also access the object with the APIs, and let's see how we can use Postman, an HTTP client, to access the REST API and see our vehicle objects and records. For this demo, we're going to use the Salesforce APIs collection that lets us easily authenticate and use some request templates. Let's try to run some REST queries. So I'm going to go in the REST API folder And the first thing we're going to do is going to describe the vehicle object. So here we have already updated the URL here, and this points to the describe call for the vehicle object. I'm already authenticated, so I can just hit send, and we'll see in the response below here all the details of our object. So for example, here we see relationships with other objects, and if we scroll further down, we'll see fields with all our very specific settings like data type, display preferences, etc. Now on top of that, we can also query for records. So I'm going to scroll down a bit on the list of our endpoints, and I'm going to pick the query endpoint. This lets us run a SQL query. Here we have also pre-filled the query parameter that is going to be passed to the endpoint. And this basically lists all the vehicles that are in database with their fields. So I'm going to hit send here, and we'll see the 4 vehicles that we saw a couple of seconds ago in the Lightning component. And here we see all the different properties or fields of our different records. This is an example of how the REST API can be used. Let's now talk about the bulk API. The bulk API is meant to perform operations on a large number of records. And when I mean large number of records, I mean millions of records. With the bulk API, instead of using real-time updates like you would in SOAP or REST and having to deal with daily limits, you move to an asynchronous mode, which lets you update and modify up to millions of records per day. And the way this works is by processing data in batches. These batches are managed with some REST APIs. The way this works is in 3 steps. First, you configure and start your job, and then the job is being performed by the platform. So while the job is executing, you can check the job status multiple times. Once the job is finished, you can then issue a third call to retrieve the results of your job. Let's now talk about the Composite Graph API. The Composite Graph API is based on the REST API. And what this allows us to do is to chain multiple CRUD operations for related objects and records inside a single REST call. This lets us organize different requests in some sort of tree, and it allows us to do optimal processing because we can group these requests in one parent request. We can also leverage the ability to roll back an entire transaction. So if we are creating, like here, an account with a contact, and if one of these 2 operations fails, we can roll back the entire transaction. If you want to learn more about the Composite Graph API, here are 2 resources. There's a blog post and a video that are linked down in the page. Let's now see an example of the Composite Graph API with a little demo. eCars include a progressive web app that lets customers create custom car configurations and save them. As a customer, I'm going to create a quick configuration. So I'm going to select some options here very quickly. And from there, I can enter my contact details. When I click Contact Me, the app is going to save the information I've supplied in Salesforce using the Composite Graph API. As an account executive, I can now go in Salesforce and see the new lead information that was entered thanks to the subscribe form. Here I can see the information that the customer provided: name, email, phone, and the car configuration. Here we'll find the settings that the customer entered in the PWA. Let's take a look under the hood and see how we saved all of this data. I'm now in Visual Studio Code, and we can take a look at how the server handles the subscription saving. So this is done with this create subscription method here. And what this does is that it calls the Composite Graph API here with a graph that holds all of our configuration. This graph object is built in the construct graph method. Let's take a look at it. In the construct graph method, we can see that we assemble the 2 different objects that come in as a parameter, the car and the lead. And here we build the graph that creates 4 objects. The first object that we create is a lead object. We then create a car object, and then we create a car configuration object. And you can see that these objects are linked with each other. The car configuration is linked between the lead object and the car object, and we're assigning keys that were created as reference IDs in the other objects. Finally, we create a car option object that contains the settings of the car configuration. And this is how we use the Composite Graph API. Apex can be used to perform HTTP requests, also known as callouts. The code in this example here is showing you an Apex callout. Note the use of the HTTP request, HTTP, and HTTP response utility classes. The external endpoint URL needs to be registered as a remote site setting for security reasons. Let's now see an Apex callout in action in eCars. eCars sales reps can also be contacted online to work on a quote directly from an Lightning app in Salesforce. Let's quickly create a new quote for our lead. And I'm going to select myself here. At the end of the card configuration, we can generate a PDF with the new code. All right, let's take a look at our lead record that was given the PDF. So here we're looking at our lead record, and if we check in related records, we'll see under notes and attachment we now have a PDF which contains the new code for the car we just selected. Let's see how we were able to generate that PDF. I'm now in Visual Studio Code and we're looking at the Apex code that handles the PDF generation. When we click on the PDF button, our Lightning components calls an invoke create service Apex method with our car configuration. The Apex method performs a callout to a Heroku application that generates the PDF. First, we configure an HTTP request object here. And we set the endpoint of this request to a specific name credential. So this is called Heroku app here, and this is configured in the Salesforce org. And finally, we set up some other HTTP request parameters. We create an HTTP object, and we use that HTTP object to send our request, and we get back a response. We then read this response status code to see if the request performed correctly. We could also reuse the request to read data sent back from the Heroku application. And this is how an Apex callout works. On top of being able to perform callouts, we can also create and expose custom REST and SOAP endpoints with Apex so that third-party clients can access them. Here's a code sample that shows a custom REST resource. Note the use of the REST resource annotation on the class with the URL fragment and the HTTP GET annotation on the method. This means that this method is registered to be fired when there's going to be a GET call on the REST resource. So as we just saw, there are many native APIs that you can use to give access to data and business logic, and we just scratched the surface here. With all of these options, it's important to understand when to use them. We won't go into the details for the sake of time here, but here's a video that you can watch to learn more about what is the best API for the right use case. As a quick reminder, you should use SOAP when you have server-to-server real-time access, REST when you have client-to-server access, and Bulk when you work with large amount of data, so millions of records in an asynchronous way, Composite when you want to do a set of operations on related objects and records, and finally you can use custom Apex, REST and SOAP endpoints when you want to expose custom business logic. There are several tools that you can use to work with the APIs, and let me give you some recommendations. The Salesforce CLI allows you to change your configuration using the metadata API and work with data APIs, for example, when you want to query, modify records in various ways. Then we have the Heroku CLI. This allows you to set up everything that is Heroku related. For example, you can configure a Heroku application and provision add-ons. There are many other third-party tools that you can use to modify and access the APIs. Here, let me highlight two of the most important ones. First, we have Postman. This is especially interesting because we have a Salesforce APIs collection that includes hundreds of example requests that work with the Salesforce Core APIs. Secondly, there's curl, also a great third-party command line utility that lets you make HTTP calls. Finally, I'll leave you a link to our integration APIs Dev Center where you can find documentation and information related to the Salesforce APIs. Let's now talk about Salesforce and Heroku Connect integrations. First, I'm going to start with Salesforce Connect. Salesforce Connect surfaces external data inside of Salesforce. The data looks just like if it's a native record in Salesforce, but actually it is never copied in Salesforce. You can set up Salesforce Connect using an OData source, or you can also create your own custom Apex connectors. The setup is very simple. You can just use a declarative tool to sync your data with your external system. The data is never duplicated in Salesforce, but it's visible as if it were a Salesforce native object. This means that you get access to the data with all of the Salesforce APIs. You can use the REST APIs, you can also call these objects within Apex, and Salesforce will automatically perform the right operations in the external data source for you to sync these objects. Let's now talk about Heroku Connect. Heroku Connect replicates Salesforce data inside a Heroku Postgres database. This is kind of the opposite of what Salesforce Connect does. This time you're pushing data outside of Salesforce into a Heroku Postgres database. And this is a great way to expose Salesforce data in customer-facing apps that deal with large number of calls with high volume traffic. By moving your Salesforce data to a Postgres database, you basically get rid of your daily limits and you can access them more intensively. Up next, we're going to take a look at external services integration. These allow Salesforce Core to access to any third-party system using REST APIs, but without having to write a single line of code. External services are a simple and powerful way to integrate with third-party systems without code. All it takes is 3 steps. First, you import an OpenAPI specification schema for the service you'd like to use. Then you select some operations from the schema. Finally, you use flow actions that are auto-generated based on the selected operations. These actions contain auto-generated wizards that allow you to set the operation parameters that are defined in the schema. At runtime, the platform will make REST calls with these operations and parameters without having you to write any code. Let's now talk about streaming events. This technology allows you to build event-driven architectures and decouple your integrations. Streaming events rely on the Salesforce Event Bus that's part of Core. Let's see how this works. Streaming events use a pub/sub event-driven architecture, and there are varieties of ways in which you can publish and subscribe to these events. If you're coming from a third-party system, you can use the Salesforce APIs to publish a streaming event. But if you're within the Salesforce platform, you can also use the Salesforce APIs, Apex, or some declarative automation tools like Process Builder or Flow to publish a streaming event. Let's take a look at the other side of the equation. If you want to subscribe to the Salesforce Event Bus and you're inside a third-party system, you can use something called the Bio protocol, which is a standard streaming protocol. And if you're within the Salesforce platform, you can subscribe with the EMP API component, the Apex triggers, or the same declarative tools such as Process Builder or Flow. There are 2 types of streaming events that you can really use here. There are platform events that are used to create custom events with any kind of format. And there are also change data capture events or CDC. And these are automatically sent by the platform whenever there is a CRUD operation that takes place on a record. Let's take an example with this diagram. It starts with a deal being closed in Salesforce Core. This publishes a CDC event to the event bus. The event bus broadcasts the event to all CDC subscribers. With that, a number of third-party systems can then execute some business logic such as updating the inventory, creating an invoice, etc. The platform itself can also execute some actions like resolving a related case. This architecture allows us to build a more cohesive and truly integrated experience for even the most complex events, as we're no longer bound by the structural limitations of point-to-point connections. We're going to finish our tour of the Salesforce platform with MuleSoft. We'll see how we can quickly integrate at scale with things like built-in connectors. What's great with MuleSoft is that you can build quickly low-code integrations that perform really well at scale. You can integrate fast with the Flow Designer, which is a declarative tool which lets you build complex flows with a rich set of built-in connectors. And these connectors offer a wide range of integrations with third-party solutions. You can also go beyond low-code by creating your own connectors or extending them with scripts. In the end, MuleSoft is also more than just a builder, it's a runtime manager. It allows us also to expose an API gateway to handle APIs and deploy across multiple environments. Let's now jump into a short demo to see how we can use MuleSoft to integrate with a third-party application. The car dealership holds an inventory of all the cars. When a car is selected by a customer, its status is set to hold. Let's look at the car details. Here I can see the car is assigned to a customer, and we have his contact details. When the car is ready, we can then switch the status to sold. This notifies the customer with a text message on their phone. Let's now see how we built this integration thanks to MuleSoft. We're now in MuleSoft Flow Designer and we're looking at our notification flow. In the first card, we subscribe to a change data capture event on the vehicle object. Each time a vehicle record changes in our Salesforce org, this triggers our flow. Then in the second card, we run a SQL query. We do this to retrieve the vehicle owner information thanks to the vehicle ID we received in the change data capture event. The third card is a transform operation that lets us format our data so that it can be sent as a text message. We extract the contact phone number and we build a personalized text message. The last card is a Twilio connector. This is one of the many built-in connectors that let you integrate with third-party systems with no code. We use this connector to call Twilio services and send the text message. And that concludes our brief glimpse at the power of MuleSoft. We've just seen the different integration options that connect the three pillars of the Salesforce platform with each other and third-party systems. Integration solution ranges from full code to no code and also include event-driven architectures. Each feature has its perks and its ideal use case, so get started by exploring them and make sure you read the documentation before starting an integration. With that, I'm going to leave you with some learning material. Check this link in which you'll find some useful resources on Trailhead or Fun Learning platform. You'll find documentation and tutorials on how to use these different integration techniques. Thanks again for watching. Make sure to like this video if you enjoyed it and stay tuned for the rest of the series. Thank you. Bye.